All right, this video is going to talk about scale factor with similar figures. First thing we need to realize is the scale factor is going to be a ratio of lengths of an image and a pre-image. Going back to transformations, image is going to be after the dilation has occurred. The pre-image is what we started with. This is going to, and right here it says, this is how much the figure, the image, what we ended with, is enlarged or reduced from its original size, the pre-image. So the scale factor written out with these words is going to be your image over your pre-image. That means the new one, what we're creating, goes in the numerator. The old, the OG, is going to go in the denominator. So this is where I always have the formula, so to speak, of new over old. And you'll see me sometimes abbreviated as N over O. This looks at when you're going to paint the walls, you're going to put a new coat of paint on top of the old coat of paint. So when we take a look at these guys right here, the first thing I'm going to suggest is if you're given all three sides of a triangle, all of the sides, easiest with a triangle, my students have seen me use S, M, and L for small, medium, and large. We're going to go ahead and on each of these, we're going to go ahead and label the small, medium, and large sides. We'll do the same thing on triangle DEF. We are going to identify the scale factor going from one of these to the other, and then we're going to switch it around and see what's going on. So the first thing we're going to do is we are going to identify the scale factor from triangle CBA to triangle FED. What this means is the first one written is going to be the original, the old G. This is where we start. And then we're going to go to and create the new one, the second one. When we are given all of the sides, we need to choose one pair of corresponding sides to use with our scale factor. It does not matter which one as long as they correspond. We'll go ahead and set up here with your scale factor of your new over your old. We're going to be putting the measurement for triangle FED in the numerator and the measurement for triangle CBA in the denominator. So what sides do we use? I don't care. I'm going to use the small side on both of them. It's less of a number to simplify. So we're going to go ahead, FED, the new, 12 will go in the numerator. And the corresponding side, 10, will go in the denominator. You must simplify your scale factors. If you leave it as a fraction, that is perfectly fine. If you put it as a decimal, that is perfectly fine. We can accept it in both ways. Here, if we simplify this down to the most simple fraction, the scale factor is 6 over 5. We also talked about that if your scale factor is greater than 1, bigger than 1, your figure is going to get bigger. If it is smaller than 1, it's going to get smaller. Here, 6 over 5 is an improper fraction, meaning it's going to come out as bigger than 1. And when we go from our original to our new, we do end up getting bigger. All right, so let's take a look. We're now going to reverse this order. So now triangle FED is going to be the old. Triangle CBA is going to be the new. So making sure that we note that in this fraction. Since we are reversing the order, the fraction will be the reciprocal. It's going to reverse as well. Meaning now I'm going to use the same exact sides. If you use different pair of corresponding sides, it'll simplify down the same thing. CBA, the 10 goes in the numerator, and the 12 FED goes in the denominator, simplifying down to 5 over 6. Going from triangle FED to create triangle CBA, it is getting smaller, and we see their scale factor is smaller than 1 as well. So let's find out if these triangles are even similar. We are going to use corresponding sides and angles to figure this out. The first things first is it gave us all of our angle measurements. Let's check this out. Okay, remembering the order of the letters matters in our triangles. J and M are going to correspond. If we look over here, J and M are both 32 degrees. K and N are going to correspond, and they both have congruent angles. Those angles are congruent. And then O and L are congruent. We have confirmed one of the two things we need to. All corresponding angles are congruent. Check. Okay? And we're going to be writing that down just a little bit. Now the other thing that we have to confirm is what we discussed before, that we've got our sides being proportional. In order for this to happen, we need to look at all three sides and find out if they have the same scale factor. So let's take a look. I'm going to come over here to my two triangles, and I'm going to label my small, my medium, and my large. Unlike above, we're going to choose a side, we're going to have to do it for all three now. Now, we are, this one does not say which one's the new, which one's the old, but when you are reading a statement, it's going to be like this congruency, the similarity statement up here. The first one is going to be the old, the second one's going to be the new, unless it's otherwise stated, like over here. So we're just going to go ahead and practice that. And we are going to treat triangle JKL as the old, or the OG, the original. It's the first one we write. And then MNO as the new, and we're just going to practice that. So we're going to be putting triangle MNO in the numerator and JKL in the denominator. Let's take a look at the small sides. MNO, small side, is 5.4. JKL, which is going to go in the denominator for new over old, the small side is 2.7. Simplify all of these. When we simplify this out, we're going to find out that the scale factor of this side, the smaller side, is going to be 2. Let's look at the medium or middle side now. Over here, MNO, the medium was 8. We're going to put that over the medium of 4. Simplifying down to 2. So far, so good. You have to check the last one, because there are problems out there that 2 of them have the same scale factor and the third does not. So let's check this large side. And look at over here at MNO first, 10. Over here, 5. And we're going to see that this does simplify down to 2. We have now confirmed all angles, all corresponding angles are congruent, and because the sides come down to the same scale factor, all sides are proportional. So we're going to go ahead and write that down. Pause it. We're saying yes, they are similar because all corresponding angles are congruent and the corresponding sides are proportional. Make sure that we're writing in parentheses same scale factor. That's how we know they're proportional. Go ahead and pause it and write that down. We'll move to the next one. All right, for example number 4. Let's take a look here and see what we're going to do. We can look at the angles and see that we've got angle Z and F are going to correspond or congruent, E and Y are corresponding congruent, and X and D are going to be corresponding and congruent. So we can check that one off the list. Now we're going to take a look at our small, medium, and large sides and see if the sides are proportional. Here's small, medium, and large. Let's look at our small side. We're going to go ahead and put the one on the second one written, XYZ is going to go in the numerator as our new. So we can act that this is the old and this is the new. So look at our small side on over here with XY, and we have the small side is 2. And we're going to place this over the small side of 9. You cannot simplify this. So let's go look at the medium. We look at the medium side back over here to the new. We're looking at 4 over 12. Well, we should already see a problem here. These do not have the same scale factor. So we're not proportional here. Okay? Now, I do want to show you what happens if you did not start with the small side. When we look at the larger side, we're going to see that the larger side would be 5 over 15. Which would also simplify to 1/3. So if we only looked at the middle and the large, we would have thought, oh yeah, these are similar because these have the same scale factor. But because of the small side, we do not have similar figures. Go ahead and write that down. We can just make it short and sweet. Because they don't have the same scale factor, they are not similar. All right, so there is your real quick rush of how we find scale factor and how we can also see, do we have similar figures based on that scale factor?